Okay, so we start lecture 5 where we left off, more or less, which is with continued unit conversions. And the next page is the one that's entitled Unit Conversions, and it has Part A and Part B, where Part A says Approximations General. So I'll, just a minute. So it's basically this page, only without the answers written in, so don't look. And, well, don't worry, we're going to go over the answers together anyway, but I wanted you to get a chance to work things out yourself before we actually go over them. The section on approximations starts with, and of course, in this case, you just have to choose from one choice or another. So the first one is, what is the height of, say, an average adult closer to 5 meters or 2 meters? We're only looking for an approximation here. And so you just need to keep in mind that a meter is approximately a yard. And so 5 meters would be about 15 feet. You know, 5 feet might be close to the size of the average adult, but 5 meters would be about 5 yards, and that's 15 feet. Or would it be 2 meters, which would be about 6 feet? Well, of the two, it would be much closer to 6 feet. 2 meters would be a little over 6 feet, but it's close to that. And so that's a good approximation. So which paperclip? Which would be closer to the length of a typical paperclip? 3 centimeters or 30 centimeters? Well, for the approximation, remember that a paperclip is probably about the, or sorry, a centimeter is probably about the width of the tip of your little finger. And so a typical paperclip, even one of the big ones, would be pretty close to 3 centimeters. Even the giant novelty paperclip that my grandfather used to keep on his desk is, I measured it, it's only 17 centimeters, not 30. So even that one doesn't get the 30. Okay, number 3, which of the following is an appropriate mass for a large textbook? For a large textbook, 1 kilogram or 10 kilograms? Well, our textbook is actually pretty heavy. I don't know, they must have infused the pages with depleted uranium or something, because the book is incredibly heavy for a paperback. But still, I would wager that it's a lot closer to 1 kilogram than 10 kilograms. 1 kilogram is about 2 pounds, so 10 kilograms would be about 20 pounds. And 20 pounds, that would be, I mean, even the family Bible probably isn't that heavy. So yeah, 1 kilogram would be much better, much closer. Okay, 200 kilometers is closer to which of these distance? 100 miles or 120 miles? Okay, so we're not getting so approximate here. 1 kilometer is a little more than half a mile. So it's actually about 0.6 or 0.62 miles if you want to be even a little less approximate about it. So it would definitely be 120 miles. Although for most purposes, 100 miles would not be a bad approximation. But if it's a choice between 100 or 120, then 120 is definitely closer. Okay. If you're filling a 12-gallon fuel tank from empty, how many liters would it take? Well, remember that a liter is about a quart, so there should be 4 quarts in every gallon. So 3 liters would not even be 1 gallon. 12 gallons would be approximately 48 liters. So you have to keep in mind, that's one case where there's actually a pretty significant difference between the metric unit that's used to measure large volumes and the English unit that's used for large volumes. A liter is really only about a quart. and a gallon would be 4 of those. And then 6, how high would a 6-story building be? Yeah, story for buildings is spelled EY, by the way. I didn't write this sheet up, so I can't take responsibility for that. And that says the choices are 20 meters or 30 meters. Well, actually it says in the question also, allowing 10 feet per story. And so that would be 60 feet. Because part of this question, of course, relies on how high are the ceilings, in each of these stories. Some buildings would be, much more for 6 stories than others. And so 20 meters would be about 60 feet because a meter is about a yard. So 60 feet would be 20 yards. That would be close to 20 meters. It's possible that it could be 30 meters if the building has really high ceilings, but that's why it said allow 10 feet per story. Okay, then part B goes on to exact unit conversions. And in this case, it means that we're not approximating, but being able to approximate units is a very useful skill because then you can check yourself on whether or not your answer makes sense. Okay, so for number 7, is converting 25 cubic feet to cubic meters. Well, you may not even have a very approximate idea on how cubic feet should convert to cubic meters, but keeping in mind that a meter is approximately a yard, you can at least keep in mind what I said about if the unit gets bigger, the number should get smaller. And so meters being equivalent to yards are definitely bigger than feet. And so you would expect the number to get smaller. Meters, in fact, meters to the 3rd power would mean that the number should get a lot smaller in going from cubic feet to cubic meters. Okay, so the extra 2 dimensions mean that we would expect a number that's a lot smaller than 25, not just a little smaller. Okay, the conversion factor table that comes inside the cover of the book and also at the end of the map section most likely gives you conversion factors directly between cubic feet and cubic meters. Length units to the 3rd power, remember, would be volume. And so you look under the heading volume on that list, and we get liters and quarts, and we get cubic inches and cubic centimeters, and we get gallons and liters. And we, down at the bottom, get 1 cubic foot equals 0.02832 cubic meters. So we can use that to do it in 1 step. Whoops. Okay, so we take the units we're given, and we can use the conversion factor. Remember, the units we're given are equivalent to that, being that over 1. And so for the conversion factor, we want the cubic feet on the bottom, along with its number, so that it'll cancel out with the cubic feet we started with. And we want the cubic meters on top, so that we get cubic meters for the answer. So cubic feet cancel with cubic feet, and 25 times 0.02832 should be 0.708. Okay, 0.708. That is a lot smaller than 25, so it makes sense given the relative magnitudes of the measurements. And in terms of significant figures, 25 only has 2. Okay, so and 0.02832 has 4 significant figures, so 2 is what the answer should have. So 0.708 would round off to 0.71 because the 0.7 and 0 and the 0 are okay to keep, but the 8 has to go. Since the first number that's going is greater than 5, that means the digit before it has to go up by 1. So the proper answer to the proper number of significant figures is 0.71 cubic meters. There are, of course, other ways to do these conversions, and just so you can get an idea or get a little more experience in doing them in other ways, because, as I've mentioned before, this conversion factor sheet that we've got with this book and with the math handout is actually quite generous in the number of conversion factors it gives. There are a lot of other conversion factor tables that wouldn't give the conversion factor between feet and meters directly. You would have to use the linear conversion factors and then go to cube them. One way that you could do it would be to go from linear feet, or sorry, rather cubic feet, using the conversion factor for linear feet, and go to inches, which you could then cube. And once you're in inches, every conversion factor just about gives the conversion factor between inches and centimeters. And so inches to centimeters. And once you're in centimeters, you can go to meters and then just cube the conversion factor. This is what I was saying also about if you have a problem that you need to do in multiple steps, which you would need to do if you didn't have the conversion factor between cubic meters and cubic feet. One good place to start would be thinking about how you can make the transition from the English system to the metric system, or vice versa, if it's a problem that requires that. And going from feet to meters obviously requires you to go from English to metric units. So you've got length units to the third power, and you might want to start by thinking about how can I go from English length units to metric length units. And like I said, one very readily available conversion factor goes from inches to centimeters. So there you go. Just cube the conversion factor and you can go from cubic inches to cubic centimeters. That just means that you have to go from feet to inches, which is easy enough. And then you can go from inches to centimeters. And then once you're in centimeters, it's really quite easy to go to meters, just using the metric prefix. And then you just be sure that you cube the prefix also. So if we have 25 cubic feet, and that's effectively over 1, and we want to go to cubic inches, you can just use the regular linear conversion factor. There's 1 foot for every 12 inches, inches on top, feet on the bottom, so it'll cancel. But since it's cubic feet and you want cubic inches, you cube that conversion factor. That means that the feet on the bottom are now cubic feet, and they will cancel with the cubic feet we started with. And at this point, if you do the math, you will have cubic inches. And I'm just going to circle that conversion factor and draw an arrow to the 12 to remind me that when I multiply through, that 3 as a exponent also applies to the 12. So if you wanted to write down the number of cubic inches, it would be 25 times 12 to the third power, or 25 times 12 times 12 times 12, if you prefer to do it that way. Now that we have cubic inches, we can go to cubic centimeters. Again, the linear conversion factor is just 2.54 centimeters for every 1 inch, but it's cubic inches, and we want cubic centimeters, so you can achieve that, again, just by cubing the entire thing inside the parentheses. And this means that the units on the bottom are now cubic inches, and they cancel with the cubic inches over here. Don't cross out the 3, though, because that still applies to the number. And if you stopped now, you could have the answer in cubic centimeters. but it would be 25 times 12 to the third times 2.54 to the third. So I'm going to circle the 3 and draw an arrow to the number just so I won't forget that it's that number to the third power. And now to go to meters. That just going from centimeters to meters just relies on the meaning of the prefix centi in the metric system. And centi means 1/100th. So 1 centimeter is 0.01 meters. That's 1/100th of a meter. You could also write this as 1 meter over 100 centimeters. You might prefer to do it that way. I'm just doing it this way because 0.01 meters reflects more directly the meaning of the word centi. It means 1/100th. And so 1/100th of a meter is 0.01 meters. But the unit we need to cancel is cubic centimeters. So we need to cube this entire conversion factor. And so now cubic centimeters in the denominator will cancel with cubic centimeters in the numerator. Again, don't cancel the 3 because that still applies to the number. Okay, and it applies to the unit that we haven't canceled out yet also. And so if we multiply this out, we get 25 times 12 raised to the third power. And to avoid any misunderstandings, I basically like to hit equals after every step. Okay, so 25 times 12 to the third power equals this. And it's that times 2.54 to the third power, which equals that. And then that's going to be times 0.01 raised to the third power. Oop, there we go, which equals that. 0.707921165. Okay, you may notice that that rounds off to 0.708 if you take it to 3 significant figures, or if you take it to 2 significant figures, it rounds off to 0.71. And 2 significant figures is what we still need because we're limited by the 25. That's 2 significant figures. The 12 inches per 1 foot, remember that's a definition. And so that's exact, which means infinite significant figures. Conversion factors between English and metric units are not exact though. So the 2.54 counts as 3 significant figures. But also, conversion factors within the metric system are considered infinite or exact, which means the 0.01 over 1, those numbers are both infinite significant figures. So conversion factors within the English system, like 12 inches over 1 foot, that's infinite significant figures. Conversion factors within the metric system, like 0.01 meters per centimeter, those are exact numbers, and so that's considered infinite significant figures. But anything between the English and metric system would not be exact, so you do have to count significant figures for that. So we got 2 significant figures for the number we started with, 3 for the conversion between centimeters and inches, so 2 would be the number for the answer. Okay, so there's that. Now, number 8. Finally, let's see converting 60 miles per hour to meters per second. Okay, again, since we have such a generous conversion factor sheet, there is almost certainly going to, in fact, I know there is, a conversion factor between miles per hour and meters per second. This is a speed. Anytime you see distance divided by time, that's going to be a speed. And we have, let's see, 1 kilometer per hour is equal to 0.6214 mile per hour. Oh, sorry. That's not what we wanted, though. 1 meter per second is equal to 2.237 mile per hour. So that's what we wanted. Thinking of a different problem. Okay, if you've got the right conversion factor to do the entire conversion of the top unit and the bottom unit in one step, then I would write the number we're given like this, because then you can say, okay, since we're converting both units at once, that's equivalent to having 60 miles per hour entirely in the numerator. And we have our conversion factor, and then hopefully we will end up with something in meters per second. That means that meters per second in the conversion factor should go on top, and miles per hour should go on the bottom so that it will cancel with the miles per hour we started out with. We saw for the conversion factor, there's 1 meter per second for every 2.237 miles per hour. So now miles per hour and miles per hour will cancel out, and we end up with meters per second as the unit, just as we wanted. And if we take, I'm going to put a decimal point at the end of the 60, just so we can use at least 2 significant figures in this. Oh yeah, there was a decimal point originally. Okay, so that was my oversight. Okay, so mathematically, all we have to do is take 60 divided by 2.237. And that is 26.821636, and I ran out of room, so that's enough. For the proper 2 significant figures, we can keep the 2 and the 6, but everything from the 8 on has to go. Since 8 is greater than 5, that means the last digit we're keeping has to go up by 1. So it's 27 meters per second would be the correct answer to the correct number of significant figures. Now again, as I said, it is fairly unusual to have a conversion factor sheet that has this many conversion factors on it. So you might have to convert the top and bottom units separately. Okay, so converting the top and bottom unit separately, we have so in other words, what we have to do is convert miles to meters and hours to seconds. And we do that separately. If you don't have a conversion factor directly from miles per hour to meters per second, then what you would need to do is convert the top unit and the bottom unit separately. So you just set about converting the top unit from miles to meters, as we would normally do, using whatever conversion factors we would normally use for that. And then you come back and convert hours to seconds later. But for the first few steps, you're going to completely ignore the unit on the bottom. Just pretend it's not even there. The problem is you can't actually forget that it's there. You're just going to pretend for the moment that it's not there, but you have to come back and change it later. So if we have, in cases like this where you're converting the top and bottom unit separately, then you should definitely write the unit as 1 unit over the other. So in other words, miles are in the top, unit or hours are on the bottom. And that way it can help you recognize which unit is being converted and which one isn't, so that you don't get mixed up. Okay, so we can go from, to do this conversion, miles to meters, it's easy to go from miles to kilometers and then to meters, because every conversion factor sheet around basically will have a conversion factor from miles to kilometers. Okay, and then you can go to meters. For hours to seconds, well, if you remember that there are 3,600 seconds in a minute, you can do it in one step. If you don't, you have to go through minutes on the way. So these are the two things that we have to do. Okay, so from miles to kilometers, we want miles to cancel. So that unit goes on the bottom. And we want to end up with kilometers from this step, so that goes on the top. If we look up the length conversion between miles and kilometers, it says 1 kilometer is 0.621 miles. Okay, so miles now will cancel, and you would have kilometers per hour if you wanted to stop and write down an answer now. But there's no reason you have to. You could keep going. Now that we've got kilometers, we want meters. Kilo means 1,000, and we want kilometers on the bottom, and we want the new unit meters on top, because that's where we want it to end up for the answer. And kilo means 1,000, so that means there's 1 kilometer for every 1,000 meters. Kilometers will cancel, and we would now have meters per hour if we wanted to stop and write down the answer. Meters are the unit we want for the top, so I'm going to circle them just to say we're there. And now what we have to do is go back and cancel the units on the bottom. The only trick to doing that is you have to remember that that means if you want the unit on the bottom to cancel, then that unit has to go on the top for the conversion factors. Okay, so there's 1 hour. We want hours on top, so it'll cancel with hours back here for every 60 minutes. Okay, so hours cancel. And we would have meters per minute if we stopped and wrote down the answer now. But we don't want that. We want meters per second. So that means minutes has to go on top of the conversion factor, so it'll cancel with the minutes we already have, and seconds need to go on the bottom. And we know there's 1 minute for every 60 seconds. So now minutes will cancel, and we would have meters per second once we work out all the math. Okay, so we got the units to come out right, so the numbers should come out right also. We just go left to right, ignoring the ones. And if a number is on the bottom, that means you divide by it. And it's safest to hit equals after each operation, just to make sure that the calculator is not misunderstanding. So if we take 60 divided by 0.621 equals, and then take that number times 1,000 equals, then you take that number divided by 60 equals, and take that number divided by 60 equals, and we get 26.838434 meters per second. And when we cut this down to 2 significant figures, it sure enough, that's an 8, becomes 27 meters per second, just like we had before. So this is an alternate route to the same answer. And as I've said before, there are many, many routes, practically an infinite number of ways that you can do most unit conversions. And there isn't any one acceptable way to do it, whichever way makes most sense to you. Okay, so that's just about 30 minutes now. So I'm going to cut the first segment here, and then we'll come back.